to cover chapter 4, practice test 8. First question, it says multiply 3/5 times 2/3. The first step, if any multiplication, we have to check if each of them is a fraction. In this case, we have the 3/5 and 2/3. They are both fractions. So our second step is going to write each of them as a product of prime numbers. In this case, we have a 3 and a 5 and a 2 and a 3. But each of them is a prime number. Therefore, we cannot do any factorization. Since we cannot do any factorization, we're going to have to cancel them out. Now, but I have a 3 and a 3 that is matching them. As we covered before, that 3 and a 3 will cancel out, and we're left with 1 and 1. Now we have to multiply straight across. 1 times 2 is 2, and 5 times 1 is 5. Therefore, our answer is 2 and 2/5. Number 2. Problem number 2 is telling us that we have 24 over 42 times 15 over 4. In this case, we have to write each of them as a product of prime numbers, in which I'm going to do on the side. That 24, what times what give me 24? 24 can be reading as a 6 times 4, and that 6 can be a 3 times 2, and that other 4 is a 2 times 2. Now 42, what is 42? 42 can be a 7 times 6, bring that 7 down, and that 6 can be a 2 times 3. Now the 15. 15 is a 3 times 5, and the number 4 is a 2 times 2. So instead of writing 24, we're going to have to write all of these. 3 times 2 times 2. Now let's write that. So 3 times 2 times 2 times 2. All over 42. I have 7 times 2 times 3. 7 times 2 times 3. Now the 15, which is a 3 times 5. And the 4 is a 2 times 2. Now let's see what we can cancel now. I have a 3 and I have another 3 there, which I can do. So this is 1 and 1. Now let's see something else. I have a 2 here and I have another 2 here. Another 2 and another 2. What else? Let's scan. Let's see. I have a 2. Oh, there's another 2 here. So they also are gone. I'm left with 1, 3 and 5, 7. Alright, now let's just try multiply. 1 times 1 times 1 times 1 is 1. 3 times 5 is 15. Therefore, you have a 15 on top over 7 times 1, which is 7. Therefore, your final answer is 15 sevenths. Yes, we can write this. Or if you do your long division, you will have 2 and 1 7. Now, for the next problem, problem number 3, they say that we're going to have 4 and 5 7 times 21 over 22. We have to check if each of them is a fraction. In this case, this is a mixed numeral. Therefore, we must change it into an improper fraction. 7 times 4 is 28. Plus the 5 gives us 33. Over 7 times 21 over 22. That's a fraction, so we'll find it. Now we must write each of them as a product of prime numbers. Now we have to do that factorization. So instead of writing that 33, we're going to have to write two numbers that will give you 33. Think about those numbers. Recall the divisibility rule. That's a 33. I believe that's 11 times 3 or 3 times 11. So 33 is going to be 3 times 11. That's 21 is 3 times 7. That 7 is a prime number, so just stay it like that. The 22, it's 2 times 11. So instead of writing the 33, what I'm going to write? I'm going to write at 3 times 11. Instead of writing the 7, I'm just going to write the 7. Instead of writing the 21, is the 3 times 7. Recall that the 7 is a prime number. That's why we couldn't break that number down. So 22 is 2 times 11. Now it's time for us to cancel. Oh, there's a 3 here, and oh well, there's 11 there, and there's another 11 here. You cancel them out, and you're left with 1, 1. Now, there's a 7 here, and there's another 7 here. Oh, look, I have a 3 and a 3. Can I cancel this 3, 3? No, I cannot, because it has to be one in the numerator and one in the denominator. So, what are we left with then? We're left with a 3 times 1, which is 3, times another 3, give you 9, times 1 remains 9. So this is 9 over 1 times 2 times 1 give you 2. Or if you do the long division, that number could be reading as a mixed numeral, which is 4 and 1/2. Problem number 4. We have 5 over 36 times 7 over 11 times 4 over 35. Let's recall our steps. Each of them must be a fraction, and they are a fraction. Since they are a fraction, so we must write each of them as a product of prime numbers. In other words, we have to factor them. The number 5 is a prime number, so you will not be able to break it down. However, the 36 is a composite number. So the 36, I can write it as a 6 times 6, and each 6 is going to be a 3 times 2, and this other 6 is a 3 times 2. Now this 7 is a prime number, 11 is a prime number, number 4 can be written as a 2 times 2, and 35 can be written as a 5 times 7. Therefore, we must rewrite each fraction with their prime factorization. So the number 5 goes 5 over 36, which is 3 times 2 times 3 times 2 times 7 over 11 times 2 times 2 over 5 times 7. Now it's time for us to cancel. So I see a 5 here and I see another 5 here. So we can cancel them out. So there is a 7 and there is another 7 here. There is 1, 2 here and there is another 2 here. 1, 2 here and another 2 here. So what are we left with? 1 times 1 times 1 times 1, which is 1 over 3 times 3 times 11, which is 3 times 3 is 9 times 11 is 99. So our final answer is 1 over 99. The next problem. Problem number 5 says that we have to find the product of 3/18 and 4 4/5. But what is the product? Whenever they tell you find the product, they're asking you to find the multiplication. So you have to multiply those two numbers, because recall, the product is the result of a multiplication statement. Now, number 5. Since they say find the product of 3/18 and 4 4/5, we have to multiply 3/18 and so 3/18 times 4 4/5. Let's double check if this is a fraction. 3/18 is a fraction, but this is a mixed numeral. For us to convert that into a fraction, into an improper fraction, we must multiply this. 5 times 4 is 20, plus the 4 gives you 24 over 5. We keep the same denominator. Now, this step comes at 36. I'm going to erase this what we had before, the prime factorization. We will repeat the same process. Now, instead of writing that 18, I'm going to have to write 3 times 6. Instead of writing that 6, I'm going to have to write a 3 times 2. Instead of writing that 24, I'm going to have to write 3 times 8. And this 8 itself is a 4 times 2. And this 4 here that I have, I can read it as 2 times 2 and bring these 2 down. Now let's rewrite it. A 3 is a prime number. I keep my 3 there. The 18 gives us 3 times 3 times 2. 3 times 3 times 2. The 24. The 24 is a 3 times 2 times 2 times 2 over 5. Well, 5 is a prime number, so I just have to write the 5 there. Let's time to cancel. So 1, 1. I have another pair here. I have another pair here. So what are we left with? 1 times 1 times 1 times 2 times 2, which give us 4 over 1 times 1 times 1 times 5 give you a 5. So the product of 3/18 and 4 4/5 is 4/5. The next part of the practice test is divide and simplify. So we have to do some division problems. Number 6, they're asking you to divide 4/5 divided by 12/5. So first step, we have to check if each of them is a fraction. In this case, we have both of them as a fraction. Therefore, we have to change this division into a multiplication statement. For us to do that, we must switch the second for its reciprocal, or we might just flip it. So 5 over 12. Now it's time for us to write each of them as a product of prime numbers. So look, you have a 5 here and you have a 5 here. So you save a little bit of work. That's 4. What times what gives me a 4? And what times what gives me a 12? Let's do the 4 first. So 4 is a 2 times 2. And that 12 is a 4 times 3. And that 4 is a 2 times 3 itself. So instead of writing the 4, I'm going to write 2 times 2 over 1. 1 over 2 times 2 3. Time for us to cancel. There's 1 here, another pair here, and I'm left with 1 times 1 times 1 is 1 over 1 times 1 times 1 times 3 is 3. Therefore, that's your answer of the division. Problem number 7. You have to divide 9/12 divided by 240. I will do this in this side of the board. Number 7. We want you to have 9/12 divided by 240. The first step is to check if these two are fractions. Well, this is a fraction, but this 240 is not a fraction. So I must make that a fraction. To make this whole number a fraction, I just need to put a 1 underneath. Now it's time for us to change that division symbol into a multiplication statement. So 9/12 remains the same. However, this 240/1 changes into 1/240. Now I must write everything as a product of prime numbers. So let's start with 9. What times what gives you 9? So I will do this in this side of the board. So that 9 is going to be a 3 times 3. I have to do the 12. That 12 we done it before is a 4 times 3. And that 4 is a 2 times 2. And bring this 3 down. 240. What times what gives me 240? If it ends in 0, then this is a 24 times 10. This 24 is a 6 times 4. And this 10 here is a 2 times 5. The 6 here is a 3 times 2. The 4 here is a 2 times 2. Bring this 2 down and bring this 5 down. Therefore, instead of writing those numbers here, I'm going to have to write the factors. So 3 times 3 here. 12 is a 2 times 2 times 3. 1 over 240, all of this. So which is 3 times 2 times 2 times 2 times 2 times 5. Now, this is the fun part where we have to match. So, there's one pair of 3 here, cancel. Another pair of 3 here. What else? There's nothing else. We're only left with 1 times 1 times 1 on top, which is 1. This is the tricky part. Look, we have to do 2 times 2 times 2 times 2 times 2 times 2 times 5. That's a lot of work. Why do you break all of these down if we will have to multiply later on? Well, by doing this step, as I explained before, is that you will always have your answer reduced to the lowest term. And this is like checking that you couldn't simplify any further. So once you multiply all of those numbers, your answer is going to be in the lowest term. So let's multiply this. 2 times 2 is 4, times 2 is 8, times this 2 is 16, times this 2 is 32, 32 times 2 is 64, 64 times 5, well, I cannot do that in my head anymore, so 64 times 5 will be 5 times 4 is 20, 5 times 6 is 30, plus 2 is 32. Therefore, the answer is 1/320. So this is your final answer. Problem number 8. Problem number 8. Problem number 8. We have to divide these two fractions. Let's check. Is each of them a fraction? No, this is a fraction, this is a mixed numeral. Therefore, we must change this mixed numeral into a fraction. So 20 over 21 divided by 3 times 8 is 24, plus 1 is 25, 25 over 3. Now it's time for us to change that division statement into a multiplication statement. Therefore, you have 20 over 21 times, I have to flip that, so it will be 3 over 25. Now let's break everything as a product of prime numbers. Let's factor that. That's 20. What times what give me 20? It will be a 4 and a 5. And that 4 is going to be 2 times 2. Excellent. Bring the 5 down. What about the 21? What times what give me 21? 3 times 7. That 3 is a prime number, so 25. What times what give me 25? Will be a 5 times 5. So let's rewrite that. For 20, I'm going to have a 2 times 2 times 5. For that 21 at the bottom, I'm going to have a 3 times 7. And for that 3 is just a 3. And that 25 is a 5 times 5. Let's cancel. So I have a 5 here, and I have another 5 here. I have a 3 here, and I have another 3 here. Can I cancel something else? No. Therefore, we must multiply 2 times 2 times 1 times 1. 2 times 2 is 4, times 1 is the same number, which is going to be 4 over 7 times 5 is 35. And that will be your answer for that division statement. And just recall that a division statement, the answer of a division statement is called the quotient. Problem number 9. This is problem number 9. In problem number 9, I have 3,900 or 3,900 over 2 and 3/5. Wow. I have a fraction that involves a whole number and a mixed numeral. But recall that this fraction bar also means divided by. So I can rewrite that as 3,900 divided by 2 and 3/5. Now, as our previous steps was, we have to check that each of them is a fraction, but this 3,900 is a whole number. I must make it a fraction by putting a 1 underneath. So that will be 3,900 over 1 divided by, what is the outcome of this? 5 times 2 is 10, plus 3 is 13. 13 over 5. Now let's change this division statement into a multiplication statement. So that will be 3,900 over 1. This changes, but this gets flipped, so 5 over 13. Now, here we have to write each of them as a product of prime number. But you might ask, well, this number is way too big. But I have a 13 here, and 13 is a prime number, so the only thing that I can cancel out is a 13 here. What could we do? Well, you either break this number with a 13 times something should be 3,900. You do a long division for that, or you could do the long factorization. So, since this is a review for everything, let's just keep reviewing. This number will be what? ends in 20, therefore it's 39 times 100. This 39, this is divisible by 3 because 3 plus 9 is 12, and 12 is a multiple of 3. Therefore, when you divide that by 3, that should give you a whole number. So 39 is actually 3 times 13. Oh, look, I'm having that 13 that I'm going to cancel. So what I'm going to do with this 100, I'm just going to drop it down here. So instead of writing this 3900, I'm just going to write 3 times 13 times 100 over 1 times 5 over 13. Now I can cancel this 13 and this 13 here. That will be the only thing that I have left to cancel. Now let's multiply. 3 times 100 is 300. Times 5 is 1,500. Over 1 times 1 is 1. Therefore, your final answer is a whole number of 1,500, or you can also rate it informally as 1,500. Let's do problem 10. Divide 6 by half. Divide 6 by half. So they're asking you to get that 6 and divide it by 1/2. So let's do that. Six divided by 1/2. You say 6, divide 6 by half. So we're having that 6 and dividing it by half. Now let's check if these two are fractions. Well, this 6 is a whole number, so I must put a 1 underneath. Now that's a fraction. But I have a division there. I must change it into a multiplication. So I'll have a 6 over 1 times 1/2. But what I'm going to do with that half is that I'm going to use its reciprocal. I have to flip it. So if I flip, that will be 2 over 1. But wait a minute. Am I going to need to break this into a product of prime numbers? You have a 1 and a 1 here. There is nothing to cancel out there. So you're just going to straight multiply now, because you have 6 times 2 is 12. 12 over 1 times 1 is 1. And that 12 over 1 is just 12. That was problem number 10, which says divide 6 by half. Once again, this 12 is also called a quotient. When you divide two numbers, the result is called a quotient. Problem 11 is a word problem. They tell you a 25-foot ribbon is cut into 10 equal pieces. How long is each piece? Well, what are we trying to do there? We're trying to divide. We're having a full, I'm going to graph it. So imagine this is your ribbon, a 25 ribbon, and you want to cut it into 10 equal pieces. You want to break it into 20 equal pieces. So when you're cutting this, it's pretty much you're trying to share something. So if you're trying to share something, you have to divide it equally. So in other words, they're trying to have to divide a total divided by the number of pieces that you want. In other words, the total is a 25 foot, cut it into 10 pieces, so divided by 10. Let's write this as a multiplication statement. Over 1, 25 over 1, times 1 over 10. Let's write as a product of prime numbers now. That 25 is what? I'll do my work on the side. So that 25 is a 5 times 5. And that 10 is a 2 times 5. Therefore, instead of writing that 25, I'm going to have to write a 5 times 5 over 1. And instead of writing that 10, I'm going to write 2 times 5. Let's multiply them now. Well, before multiplying, we have to cancel. There is one 5, and there is another 5. So you're left with 5 times 1, which is 5, over 1 times 2 is 2. Excellent. So that's your final answer. But 5 half what? What units are we talking about? They're asking you how long is each piece. If each piece is measured in foot, then we have 1/2 feet actually. That would be feet. The real one in foot. So 5 feet. But how much is 5 feet? You do your long division. In your long division, you will obtain that it's 2.5 feet. That's how long each piece will be. Okay, let's keep moving with problem number 12. We have problem number 12 in which we have to find the missing number. In this case, we have the box equals to 6/25 times 300. What are we missing here? That's what we have to ask ourselves. These two are the multipliers, and the one here is the product. So we're missing the product. In any case that you're missing the product, all you have to do is multiply those two numbers. So in this case, we just have to multiply these two. Now, but it has to be a fraction, so I'm going to have to write a 1 underneath here. And then I will go, I have to write everything as a product of prime number. So that's 6. That 6 I'm going to have to do after 3 times 2. That 25 I will have to do as a 5 times 5. And the 300 is going to be 3 times 100. And that 100 is going to be 10 times 10. And each 10 is going to be a 2 times 5. Then I'll have a 2 times 5 there. Therefore, let's rewrite this. So 6 is 3 times 2. 25 is 5 times 5. The 300 is 3 times 2 times 5 times 2 times 5. All over 1. It's time to cancel. 5 and a 5. Another 5 and another 5. What are we left with? Initially we had a 3 times 2, which is 6. 6 times, well, here we will have a 3 times 2 times 2 is a 12. So pretty much we have a 6 times 12. What is 6 times 12? 6 times 2 is 12. 6 times 6, 6 times 1 is 6, plus 1 is 7. So it will be 72. So you have a 72 over 1. And 72 over 1 is just 72. Therefore, your missing number is 72. So in these problems from 12 to 15, all we have to do is try to identify what are we missing. If we're missing a multiplier, remember that you have to if you're missing a multiplier, you have to divide. What are we going to divide? The product by the non-multiplier. If you are missing the product, then we just have to multiply those two numbers or fractions. Let's look for the following problem, which is 13. What do we have in problem 13? In problem 13, we have a 3/5 times something equals 60. So let's do that problem. Three-fifths times box equal 60. 3/5. So what are we missing here? What do we have? If these two are the multipliers, this is a product. Therefore, if we're missing a multiplier, we have to divide. We divide this right here, that is the product, by the non-multiplier, which is a 3/5. So let's do 60 divided by 3/5. But this must be a fraction, so put a 1 underneath and change this division into a multiplication statement. So it's 60 over 1 and flip that over, so it's 5 over 3. So let's do the same procedure here. That 60 must be breaking into product of prime numbers, which is going to be 6 times 10, and this 6 itself is a 3 times 2 times a 2 times 5. The 5 is a prime and the 3 is a prime, so instead of writing 60, you're going to have to write 3 times 2 times 2 times 5. 3 times 2 times 2 times 5, all over 1 times 5 over 3. Time for canceling. I have a 3 and have another 3 here. So you're left with 2 times 2 times 5, which is 20 times the 5 there is going to be 100. 100 over 1, which 100 over 1 is just 100. Therefore, your missing multiplier is 100. Let's go for the next following problem, which we have problem 14. In problem 14, we're having 7 and 2/9 times the box equals to 4 and 1/3. Let's do that. Remember, it's so important that you identify what are you missing. Identify all the things in the multiplication statement so you know what to do. You either multiply or divide. So, problem 14, we have 7 and 2/9 times a box equals 4 and 1/3. What are we doing here? We have to identify. These two are called the multipliers. And the number here, this mixed number, is called the product. So what are we missing? We're missing one of the multipliers. So if you're missing one of the multipliers, what you have to do is you have to divide the product divided by the non-multiplier. In this case, the product is 4 and 1/3 divided by 7 and 2/9. Be aware of this division. They must be two fractions. So let's convert this into improper fraction. So 3 times 4 is 12, plus 1 is 13. So it will be 13 over 3 divided by 9 times 7 is 63, plus 2 is 65 over 9. Now is the time for us to change this division into a multiplication statement. 13 over 3 times 9 over 65. Time for us to write everything as a product of prime numbers. 3 is a prime number, 13 is a prime number, 3 is a prime number, 9. What times what gives me 9? 9 is 3 times 3. And that 65 there is a multiple of 5. 5 times what will give you 65? Let's see that. So 65 divided by 5. 5 goes into 6 once. 1 times 5 is 5. 6 minus 5 is 1. Bring this guy down here. And you have 5 goes into 15. 3 times 5 is 15. It went evenly because this was a multiple. This was divisible by 5. So 5 times 13 gives you 65. So let's rewrite this. 13 over 3 times 3 over 5 times 13. Let's see what we can cancel. I have a 13 here and I have a 13 here. I have a 3 here and I have a 3 here. What I'm left in top is 1 times 1 times 3, which is 3, over 1 times 5 times 1 is 5. Therefore, your missing multiplier is 3/5. Remember that every single time that you're missing a multiplier, you must divide. what do we have to divide? We must divide the product divided by the non-multiplier. Knowing that, let's do problem 15. $450 equal box times 12 over 20. Let's identify what are we having here. We're having a multiplication statement. This one here is called the product. These two here are called the multipliers, and one of them is missing. So if one of them is missing, what we need to do is we need to divide this product divided by the non-multiplier. So you will have 4 divided by 4 over 50 divided by 12 over 20. Let's change that into a multiplication statement. 4 over 50 times 20 over 12. Now let's write everything as a product of prime numbers to make things easier. 4 is a 2 times 2. That 50 is going to be 5 times 10. And that 10 is going to be a 2 times 5. That 20, what is that 20 going to be? 4 times 5. And this 5 here, this 4 here is a 2 times 2. Bring the 5 down. That 12 is going to be 4 times 3. And that 4 is a 2 times 2 times 3. Now let's rewrite everything here. So that 4 is going to be a 2 times 2 over the 50 that we have there, which is a 5 times a 2 times another 5. And the 20 is a 2 times 2 times 5, 2 times 2 times 5, over 12. 12 in this case is a 2 times 2 times 3. Let's see what we can cancel here. We can cancel a 2 and a 2. Here's another 2. Here's 1 2 here. Here's a 5. And that's it. That's all I can cancel. So on top I'm only left with a 2. And the bottom I'm left with a 5 times 3. So I will have on top a 2 over 5 times 3 is 15. Therefore, that will be your missing multiplier. So remember, once again, if you're missing a multiplier, you must divide the product divided by the non-multiplier.